Hello, everyone. My name is Parag Jain, and I work as Principal Data Platform Architect at Snowflake. Today, I'm going to walk you through a great way of running your custom pipelines and data pipelines in Snowflake and using Snowpark and Java UDF. You can use any language you want, and you can use any tool of your choice. Isn't that great? We will also go over some of the examples to deploy your custom code inside of Snowflake and bind it with Snowflake. Today, we're going to cover some of the lab steps, and then I will introduce you to the concept of Snowpark and Java UDF. And finally, we will share some examples and run them in our hands-on lab. Please type in any of your questions do you have in the Q&A box, and one of our experts should be able to help you throughout the session. Now, there is already a lab guide set it up for this hands-on lab. Feel free to use it at your own pace and also within the session. For the first 10 minutes or 15 minutes of the session, I'm going to go over some of the introduction of Snowpark and Java UDF. You will need some familiarity with the Scala, so it will help you going through the hands-on lab much more smoothly. And this hands-on lab is obviously built in Scala, so you will need SBT, which is the de facto tool for any Scala project. You will also need a Snowflake account and a Git installation as well, because we are going to clone a Git repository provided by Snowflake Labs right on your desktop. Now, Snowflake is already a great data cloud platform, and it supports multiple languages and multiple isolated environments to run any workload that you want. So why even care about extending it to a software API? Well, the answer is simple. Snowflake has always solved the problem by focusing on where we can truly differentiate. And we want to make sure that Snowflake can do more, and by making it easier to the developers, and so you can push your codes inside of Snowflake and then run your pipeline closer to your data sets. This way, you can make Snowflake do more. So what is Snowpark API? Snowpark is a new developer experience for data engineers, data scientists, and data application developers to use Snowflake in their day-to-day work. It allows you to write Snowflake code in your preferred language and your tool choice. You can execute this code inside of Snowflake whenever you want. So Snowflake enables you to write code in the language of your choice, build and debug code in the tool of your choice, and manage the execution of the code from one platform, that is Snowflake. Now, Snowflake has Snowpark, which is in public preview for all your AWS deployment. So today we support Scala, and in the future, we will be supporting Java and Python as well. So why should we even talk about Snowpark? And where should we even use it? To answer that, I'm just gonna wear my data engineering hat. And everybody who loves coding in SQL, they frequently use Snowflake to build the pipeline in SQL. But what about the other data engineers who don't know advanced SQL and they still want to use Snowflake for their data pipelines? Well, Snowpark is our answer. The Snowpark API is built for running your code inside of Snowflake. The core abstraction of Snowpark is a DataFrame library. And all the data engineers who love to code in DataFrame library will find it how easier it is to use this library, how easier it is to join the data, how easier it is to merge data without actually writing SQL code or advanced SQL. This way, you can make your transformations easy and deploy the code close to Snowflake. This is all about transforming data, right? So we want to write some code that can be deployed close to the data. And then this custom code is built by you. So how do we actually deploy this code? The Java UDF is our answer. With Java UDF, a user-written function can be called inside from Snowflake. Java UDFs are scalar. That means You input one row and then you get one row in output. Java UDF can also contain both new code, and you can also register any existing methods and functions that qualify for scalar functions in Snowflake as well. Snowflake currently support Java UDF in version 8, 9, 10, and 11. Both Snowpark and Java UDF can be used together to build a very powerful pipeline without adding any external compute resources. Let's take an example. Imagine you have a client code, and previously you were able to connect to Snowflake using a variety of connectors like Python connector, ODBC, JDBC, Go connector, and whatnot. But now you have a powerful data frame library at your disposal, which is Snowpark. Now, what Snowpark library can enable you to do is you can deploy your custom code as a jar file inside Snowflake. And later on, you can use that jar file using simple SQL functions and bind it together with the Snowflake kernel. Once that is done, you can use any data frame and create your own DAG, and then this DAG will be lazily executed in Snowflake. With that, we avoid doing so many network hops, pulling the data into memory, throwing the data back to Snowflake. So we avoid all that, and then it reduces the whole data transfer between your client and Snowflake database. Now let's take one more example where we can see how Snowflake, Snowpark API library, and the Java UDF can come together and give you an overall heuristic user experience in building your pipeline. So Java UDF is a scalar function which takes one row and spits out one row, but using a Java UDF within a Snowpark API library code will enable you to push your custom code inside of Snowflake. So you don't need to run SQL commands to, let's say, for example, doing timestamp conversion, doing some date time conversion, let's say finding out PII information out of some text, scoring and inferencing. So the use cases are enormous. Once the scalar function is deployed inside of Snowflake, you can call that scalar function right from your Snowpark library. Just like you see this on your screen, where I'm using a has PII function right from the Snowpark and calling that function inside of Snowflake. We can bring all this together in our hands-on lab and see with a quick, simple example of how Snowpark and Java UDF can come together to build a very effective and efficient pipeline. All right, so let's look at some of the steps that we are going to perform in our hands-on lab. First thing first, you need a Snowflake account. If you already have an account in AWS, you don't need to create this new free account. But for all of my folks who actually doesn't have a Snowflake account, we provide a free $400 worth of credit, which will stay with you for 30 days in a trial version. And you can create your own account by going to signup.snowflake.com. Next, we are going to install Git, which is the de facto tool for any SVN. Then we are going to install SBT, which is de facto tool for any Scala project. Next, we're gonna download the sample data file and libraries from Stanford NLP and from a Kaggle, which has sentiment analysis data source for 1.6 million tweets. Then we're gonna configure our Snowflake account and provide the connection details in the connection file. Next, we're gonna create a data frame. And with that data frame, we are also going to create Java UDF, which will be automatically deployed in Snowflake when we execute our code. We will, once we perform the sentiment analysis, we will save off the results back into Snowflake, and then we'll test the result set with a simple example. So with this, let's jump onto our lab. So I just came out of the presenter mode, and I'm so excited to share this hands-on lab with you guys. We will go over all the steps mentioned in the prerequisites one at a time. But first thing first, let's create a shiny new Snowflake account for all of you who doesn't have one. And let me pull up the prerequisite slide. Here we go. Okay, so let's start by creating a basic environment for our lab. We are going to, first we're going to create a Snowflake account. In order to do so, you can just click on signup.snowflake.com and you will get to this screen where you can fill in your basic details and click on continue. Now, I already have a Snowflake account, so I don't need to do that. But in case you don't, you get free $400 worth of credit and 30-day trial period with Snowflake. When you go on to the next screen, be sure to select the enterprise version and Amazon Web Services as your cloud service provider, and you can select any region. For the purpose of this lab, I'm selecting this US West Oregon. Now, once you click on Get Started, you will receive an email with the next steps with the URL, wherein you can click on that URL and create your account and provide a password for the account. Once you create the Snowflake account, the next step is to download the dataset. You can follow the links in the description to download the Kaggle dataset. This is 1.6 million tweets, which we are going to analyze for sentiment using the Stanford Core NLP library, which is the second link in the description. We are not going to go over the details of how these libraries are created. We're just going to consume them in our Java UDF to provide the sentiment analysis over the data set. I'm going to put these two files in one folder. There you go. So just going to copy these files and then paste them into one folder. Once the files are there, you can unzip them. There you go. So my CS, so this is my training data set, or this is my data set that I'm going to use. It has 1.6 million tweets. And then I have my Stanford Core NLP full 2015 folder. This has all the jar files that we need for the demo. We actually don't need all the jar files, sorry. We only need 4 of these jar files for this demo. And the one that we need are SLF4, EJML023, the Stanford Core NLP, and the Stanford Models NLP. So let's copy this back in this original folder. So now you have 5 files that we need for this lab. So what I'm going to do is I'm going to create a new folder, call it as TMP, and put these files which we don't need inside that TMP folder. All right, so this way we are much more cleaner. Now we need to upload these files to Snowflake, and for that I'm just going to create a folder called it as files to upload, and then put all these files in this folder. Clean. So this way we know these are the files that we need to upload and send it to Snowflake, and the files that we don't need. Now next step is to install Git and SBT, which is our de facto tool for any Scala project. And I'm going to do this through an development environment. You can use any, but for the purpose of this demo and this lab, I'm going to use Visual Studio Code. All right, and then open this lab folder. Now we see that there are files that we need to upload and the temporary file So we are in the right folder. One thing that we need to do is open a new terminal, and in the description of this hands-on lab, you will have the link to clone the Snowflake Labs demo, which has all the necessary code that is required for this lab. I'm going to go back. Yeah, but before that, you need to install Git. Takes a few seconds. And we also need to install SBT. So let's install SBT. Right, Git is required to clone the repository. So paste the command, and the command is git clone and the URL for the guide demo. So once we do that, it's very, very quick. It takes less than a second for me. Once you do that, you need to go and put this folder inside the guide folder. So I'm just going to do that. Move. There you go. So now it has. Let's just quickly walk through this this guide demo. It has a built .sbt file, which is required for any Scala project. It has the source code that we will need require for this lab, and it also has Snowflake connection.properties. Now, what this connection.properties do is it creates a Snowflake connection based on the URL, username, and password that you have provided, and it has some commented text for your private key file if you have one. And now, for the purpose of this lab, I am going to use the private key file because I don't want to show my password to the whole world. And it's one of the best practice. So password file, or my private key file, sorry, is stored in my local a dot key, I believe, right? Key.ph, sorry. So this is my private key file, and the username that I'm going to use for my account. I don't need the password. Feel free to use the password and not the private key for all of you who has just set up the account. Any role that you're going to use, and that should have create access. So I'm going to use, for the purpose of this demo, sysadmin, and I already have a warehouse. I'm going to call that warehouse here. And for those of you who are new to Snowflake, warehouse is your way to communicate and compute resources on Snowflake. You can go ahead and create any database. I'm going to use a database called as TweetsDB, and I'm going to use public schema for this lab. Now, how do you create those objects, right? It's very easy. When you log into your Snowflake account, go to databases, click on create, and just type in the name of the database that you want to create. And I'm just going to call it sentiment analysis for Twitter data, right? There you go, and then it's just got created. Now for the warehouse, same thing. You can create your own warehouse. So for example, lab underscore small underscore WH, and then you can select how many credits that you want to burn for this warehouse. It's very simple. For the purpose of this lab, I'm selecting small. You can also tell Snowflake on number of clusters that you want to use for this warehouse. If you just keep one, there will be no clusters. There will be no scaling. But if you select, let's say 3, you can tell Snowflake that starts with 1 cluster, and as the load progresses, as you get more load, you can maximize the cluster size to 3. This way you don't burn a lot of credit. You can also select an auto suspend policy. By default, it can be set to 0 as well. I mean, you can just, as soon as you start your warehouse, you can kill it. But I'm choosing 5 minutes. So if there is no activity for 5 minutes, this warehouse is gonna shut itself down. And whenever you hit a query against your database, it's gonna start again. That time is apparently minuscule. It doesn't take more than a second or microsecond to start and stop this size of warehouse. All right. So once you finish writing all the details, click on finish, and then your warehouse will be ready. All right. So back to our lab. So I provided all the necessary details. Now let's quickly check on how to connect using these details that we have provided. And I just missed one thing. So basically, this is the URL that you need. So you will have a different account name, and then then a dot, and then snowflakecomputing.com. So you select that and then put that in the URL field, right? All set. So we have set up all the connection properties. Let's quickly test this. And in order to test this, you need to be in the SF guide directory, right? And then the command to test is simple. It's just called sbt space, and then inverted commas, run main. And the code that we are using is hello world. And I'll quickly go through this code as well. So just click on hello world. Right now, what it's doing is it's trying to connect using the details that we have provided to our Snowflake environment. Now, in order to upload these files, we are going to use another source in our source directory. It's called UDF setup. So yeah, so we are now connected. So it seems like the settings that we have provided are now working. The connection properties are working. Now, these files are big. Some of these files are about 300 meg. So we need to make sure that all these files are uploaded before we can run any code. And for that reason, before even going in further details, I would like you guys to initiate this command. It's called sbt. Same thing, run main space, and we are going to use UDF demo setup in the source to put these files, which are inside files to upload folder in Snowflake. It will do all the necessary step and we'll go over it, don't worry about it. But since it takes time, I want to make sure that this process is started. Okay, so let's run this. This will take some time depending on the network speed and things that we are planning to do. We're planning to put almost 1 gig worth of data onto Snowflake servers. So while this is running, I want to share some architecture diagram with you for the whole project and what we are trying to do. And it looks like this. So basically, we have our client application on the left-hand side, which is Visual Studio Code. And in this application, we are creating a code with the language of our choice using Snowpark API. We have tweets data saved in the CSV file in Snowflake, internal stage, and so as the NLP jar files that we got from the Stanford core NLP. We will create an anonymous function using Scala. That anonymous function we will register as a user-defined function. And as soon as we do that, Snowpark library will know and will automatically deploy this code as a jar file, as a serialized executable inside of Snowflake. In the next step, we will create some data frames. Now you can perform several operations on the data frame. You can join them. You can select particular columns, and you can do some kind of transformations. So every time you do something with the data frame, it creates a lazy execution plan, or a DAG as we call it. That DAG is not executed unless you call an executable method on the data frame. In our case, the executable method is show. Now what happens is it will query the data, including the UDF code that we have called in our show method. And the warehouse and the virtual warehouse will go and fetch the results from the jar file using the Twitter data that we are sending. So using the text, it will analyze the sentiment of the data using the jar files, using the NLP core jar files, and it will send the results back to our client program. Now note that during this whole process, there is no data movement between our client and Snowflake. All the code that we are trying to run is running, in fact, inside of Snowflake using the data in the Snowflake. So there is no data movement as such between these processing calls between the client code and the Snowflake. So you don't need to transfer the data to your client in order to execute the function on the data. The execution of the function can live inside of Snowflake using Java UDF, and that is made possible through the anonymous function in Snowpark library. Now there are other ways to create user-defined function as well. You can register a permanent user-defined function in Snowflake using Snowpark API as well, but that is not covered in this HOL. You can go and look for it in our docs.snowflake.com. And there are many more techniques to register an anonymized function and to register a named function that you can use over and over in different sessions. So basically, the anonymized function you can only use in that particular session. But a named user-defined function you can use in any session. And there is practically no difference in them. It's just you need to register a named function with Snowflake if you want to use it in various sessions in various programs. So this is a short description and introduction about our architecture. Now let's go back to our UDF setup program and see how far we have gone, and also take a look at the UDF setup program and see what it is doing, how it is sending the data files into Snowflake. Where are those data files located? Okay, let's go back to the Visual Studio Code. All right, let's open up the demo setup program. All right, so what's happening here is we are first trying to import the Snowpark APIs and the functions API. Now we are trying to set up the files needed for the Snowpark demo, and we are trying to push the downloaded file into Snowflake into something we call as internal stages. Now, for those of you who are not familiar with internal stage, assume that as a S3 bucket, which are maintained and managed by Snowflake internally. So we will try to create those two internal stages, where the first one will be for Snowpark demo data, and then the next one will be for the jar files. So we are creating two internal stages here. And we are going to upload the files that we put in the files to upload directory. Now, in case if you have another directory, if you named it differently, you can replace the files to upload folder name with something else that you prepared. Then we are also trying to put the CSV file, the 1.6 million tweets, into our demo data internal stage as well. And all the jar files that we find in this directory in Snowpark demo UDF dependency jars internal stage. Next, we are trying to create a method in order to upload these files in the internal stage. The arguments for that method are simple. Either we will provide the name of the file or some kind of file pattern, and we will provide the name of the internal stage while uploading this file. The method to run, to create an internal stage is just by calling a simple SQL statement called create or replace stage and with the stage name, and then starting to upload these files using the file processor in the session. The method that we are going to use here to upload these files is called put. This is similar to any other ODBC or REST API or Snow's SQL command where you put the file in internal stage. Now once these files are uploaded, we will also list the files just to see if the files are uploaded correctly. This method for loading the files can be iteratively called inside the main method. Now in the main method, we are trying to create a session first with the connection properties file that we just updated. Then we will call the upload demo files method 2 times, one for the data file and one for the jar files. So what we have completed so far is our initial lab setup. So if we go back to our architecture diagram, so we have now uploaded the core NLP jar files inside Snowflake, and we have also loaded our CSV tweets data inside of Snowflake. Now let's create a program to interact with these files using our client code. And for that, this is the main Scala program that we are going to write for this lab. And that main method or that main program is called as UDF demo.scala. So let's just open up a new terminal to start and interacting with this program. Now, those of you who have finished uploading the files can follow along. I'm going to go over this code, so this will take another few minutes, and then I'm going to run this program. So this gives you some time if you're still waiting on those files to be uploaded. So this is our main program, the UDF demo.scala, where we will bring everything together. The jar files that we have uploaded, the CSV file that we got in there. So let's just quickly look at our data set and then jump onto the code and see how we are processing that data. So let's go back to the Kaggle data set. Let's check number of columns. Okay, so it has 6 columns. And the first column is target, ID, then a date column, then a user column, and then a text column. All right. So let's go back to the code. So what we need is to define a structure around that, around this CSV. And in order to do that, Snowflake provides various methods, various API libraries, similar to any other data frame library, like defining a structure field and structure type. And Snowflake also provides, through the Snowpark library, a method to actually save the output or create temporary outputs for your interim or staged results. Snowpark also comes with a variety of functions, very rich set of data frame operations and transformations. So let's quickly have a look at those before we actually move forward, just to set some context around Snowpark data frame library. So in order to do that, you need to go to docs.snowflake.com. So again, it's docs.snowflake.com. And then scroll all the way to your left, click on API reference, and then scroll down, go to Snowpark. In Snowpark, you have a few options. You have the API reference option, and then you also have getting started with Snowpark option. So let's open these two in the new tab. Now, everything that we are trying to cover in this hands-on lab is already present in this guide, this getting started using Snowpark guide. And it walks you through the same step that we have gone through so far, right from downloading the repository, setting up your lab environment, and also setting up your connections to Snowflake. And it has all the links to download the data files and to download, install tools that we are going to use in this hands-on lab. So for anyone who just joined in, or for someone who is lagging behind this hands-on lab, can refer to this hands-on lab guide. And again, it's located in docs.snowflake.com, all the way in the API reference down to Snowpark. Now let's go over the Snowpark data frame library. In order to do so, when you are in the Snowpark development guide, scroll to your right and click on data frame. Then you will see that the data frame library comes with a rich set of methods and tools to interact with the Snowflake database. It has many methods for built-in transformations on your data frame, and all these transformations are lazily executed and until you run an action on it. These actions will perform an evaluation of this data frame. And during this evaluation time, what will happen is it will create some SQL queries, and Snowpark will send those SQL queries to the server. And Snowflake will run those SQL queries and return the results back to the Snowpark data frame. There are many methods, like I said, and there are many filters which act as a where clause. And there are many examples in this API reference where you can refer, create your own data frame and apply those in your own programs. It also has the list of action methods, which will actually evaluate the data frame and make a hop to the Snowflake server to fetch the data, to actually query the results, and then fetch the results back to your client tool. This also has a list of transformations and aggregations, and just all the fun thing that comes with any data frame library, wherein you can perform file operations, you can have merge of two data frames, you can join the data frames. It also has a rich set of functions that you can refer to with simple examples. So I do encourage everyone in this call to go over and look at Snowpark API reference guide as well. So now back to our code. Let's quickly walk through the code, and then we will run it and then see how the output is generated and what's happening in the output as well. So let's run this piece of code and see how the UDF is created, and then make a call to that UDF and see what it's doing. So go to the SF guide, clear, and then the command is sbt run main UDF demo.scala. Sorry, just UDF demo, right? And I also walk you through what is happening here. So we'll go in the main method. So in this method, what we will do first is we will load the data file, the CSV data file that has 1.6 million tweets into Snowpark data frame, and then we will create a user-defined function that will analyze a string and determine the sentiment of words in that string. Next, we will call the function on each value in a column in the data frame. Then we will create a new data frame that contains the column with the original data, the text, and the sentiment about that text coming from the UDF call. Then we will create a new data frame that just contains the rows where the functions determine that the sentiments are happy. And then we will load that data frame back into a Snowflake table. All right, so let's take a deeper look at the example and the output to see how the Snowpark library does this. So first thing that we do is we need to create a session with Snowflake. And in order to do that, we utilize the session builder property, session builder method, sorry, and use the configuration file for Snowflake connection. Once we create that connection, using the create method, that session can talk to Snowflake. We also utilize, inside of that session variable, utilize the implicit names. So we import those implicit names in the session variable. What that helps us do is instead of calling the long column name by using $, we can just call the column name by using an inverted comma. So basically a shorthand expression made possible through the names in the implicit method. Now, once we import that into our session variable, next step is to get the data, not actually get the data, but have a pointer to that data through our data frame, right? So basically we are trying to connect a data frame with the data inside the CSV file that we uploaded inside of Snowflake, right? Now, in order to do so, we need to create a structure around this file. And this is made possible using the Snowpark types import. And that helps us define the string type, struct field, and struct type on the column. Now, this is similar to any other data frame library, be it Pandas or be it Spark, right? So you can customize the structure of the file using a sequence of struct field around the file. So we have 6 columns right now in the file. We have target column, ID column, date column, flag column, user column, and text column. For the purpose of this example, we are going to define them as all strings and then load them into a data frame. That data frame, we're going to call it as original data. So orig data is our first data frame that has a similar structure, exact same structure as the file. Right now, while defining the data frame reader, we can tell the session variable to first read the file and then apply the schema using the .schema method. And then we can daisy chain all these all the methods that we want to apply on that data frame. We can tell the data frame reader that the compression type using the option method. The compression type is gzip. We can tell the data frame that this is a CSV file. Note that these variable names, right? These are the file name, stage name that we have declared in the demo setup script. So if you go to the demo setup script, you'll see the data stage name and the data file name, right? These are the 2 variables that we declared in the demo setup program. So we are just calling those, calling the same stage name and same file name and reading it inside of a data frame. So when we make this call through Snowpark doesn't actually go and fetch the data back to the program. It does not. We want to highlight that because so many of you will think that, okay, yeah, we started reading the file, now the data is in memory. No, it's not like that. It's just going to lazily evaluate the objects in the file. We're not going to pull that data in memory for now. Now, next is we will try to read the full file, in a data frame, and we will drop the columns that we don't need from the file. So we don't need the target IDs, date, flag, and user, right? So if I go back to my file, the first 5 columns were useless. I don't want these columns. I don't want to do any kind of analysis on these columns. So I will remove the first 4 columns from this file. Only thing that I need is the text column, right? Oops. So that's what I'm doing here, right? That's what I'm doing. That's what I'm trying to drop, calling the drop method and dropping all those columns which I don't need here. Next is, remember the thing that I talked about, the lazy evaluation. That's what happening here. So when we create a data frame and put the file there, and then in the next data frame we drop all the columns that we don't need from the original data frame, right? So in this new data frame, we only have the text column. And now we are calling a method, show. Now this is the action method, and that's what gonna cause the execution and go to the Snowflake server, fetch the data, and bring the data back to our client tool, which is this VS Code. So this is the only time when it actually makes a hop to the server, not here, right? So all this is lazy evaluation until we call an action on the data frame, right? This is really important to understand. So let's see what happens up until here, till we call this show, right? All right, so we ran the program. It tried to make a connection using our connection.properties file. Now, after this, it says actively querying parameter Snowpark lazy analysis from server. So basically, yes, you have a connection, but you're going to lazily evaluate all the piece of code that you have written. So setting up the data frame. So basically, up until here, no calls made to the Snowflake server. Again, no call made to the Snowflake server, so there is no SQL, there is no query or fetching happening here, unless we come to the retrieve part, right? So retrieving the text for the first 10 tweets, right? So this is where we call our show method, right? And then it goes and makes a call, and when you actually make this action method, when you call this action method on the data frame, what it does, it evaluates whatever you have done for this data frame to arrive at this data frame, to calculate this data frame, and then it generates the SQL statements. And in our case, the SQL statement happens to be this. Basically, the original data frame, which is calling every string, and then in the new data frame, we're only calling the text column from this from the old data frame, and it retrieves those 10 tweets to us. Simple. So basically, we created a data frame using the original CSV data file. Then we dropped the 4 columns, 5 columns that we don't need from the data file. And only have, so at this point of time, this data frame only has the text column. And then we showed the first 10 tweets from the text column. And it actually tries to create the file format that we want using the schema that we have created. So you see this SQL code. It's the result of this this is schema that we have created. It's trying to tell Snowflake that create a schema on top of could create a schema or a file format on top of the CSV file that we have uploaded in the internal stage. And what we are doing in these two data frames is just a transformation. So the drop method, the limit to 100 is actually filter or limit the output to only 100 rows, is actually the transformation that we are doing in these two data frames. So all this is lazily evaluated, and Snowpark library prints the information, information and information in the execution window about what queries that are generated during this operation. So at this point in time of our program, we now have 10 tweets, or actually we have 100 tweets loaded into this tweet data frame. So let's move down in the code and also try to analyze further what we can do with our data frame using the user-defined function. So right here. Now next, we will create a user-defined function using the method from Stanford Core NLP, the analyze method, which we will use to analyze the sentiment of the text, right here. So if we back up a little bit, we are calling, from the Snowpark library, we are calling Snowpark functions. What this does is this enables us to bind a function and a user-defined function, bind an external code with a user-defined function, and help us deploy that as an executable, as a serialized executable jar file, right? And this is that external method. Now this can be anything. This can be any piece of code, but remember it has to be a scalar function, meaning you input one row and then you get something in output as a single value, as a single row. It happens that we are using the Stanford library here, right? The Stanford library, and then we are trying to break this text, for different properties, and then we are, analyzing the text natural language using natural language processing algorithms for Stanford Core NLP, and then we are generating the annotation about the text. We are generating the sentiment about that text, right? We are also generating, it is tokenizing it, it is parsing it, and then ultimately generating the sentiment. So that's what's happening in this code. Okay, so let's analyze the output now. So we made a call to this analyze function using our UDF. So let's see what happened up until here, right from adding the dependency, right? So we just retrieve the text. Now we are adding the dependency, right? It adds these jar files into a stage, right? Like the dependency that is specified earlier, right? All these dependency. Then Snowpark library creates a temporary stage for this jar, as you can see right here, adding these files to the temporary stage. Then it uploads all these files to this temporary stage, right here, right in this piece of code, create temporary stage. And it actively monitors the whole process using a query tag. Now, for those of you who doesn't know query tag, it helps you segregate a query from all other queries that are running on your warehouse. So if at any point of time you want to see what happened to that to this user-defined function, you can simply go to your query history and look for this tag. And then you will see all the queries running in this session for this particular tag at this particular point of time, right? Next is you can also, this Snowpark code also helps you, to upload the jar files for Snowpark and for your application code into the stage. And then Snowpark also compiles your UDF and uploads the jar file for that UDF inside of Snowflake. Meaning the function that you created, the UDF function that you created in your choice of tool, which is Visual Studio, will be deployed as a jar file automatically by Snowpark inside of Snowflake. Isn't that cool? You don't really have to, serialize, deserialize this code. You don't have to put them in a executable format like jar file and deploy it by yourself. Snowpark automatically does that for you at the runtime. So it deployed the UDF as a jar file to the temporary stage inside of Snowflake within less than a second, basically. So all your scalar function less than a second deployed into Snowpark and ready to use. And we can see this right here. Right, so you can see that it's creating a query and then it's creating those temporary function, binding it with the jar file. So you'll see these exact jar files that we have saved in our internal stage, binding it using Java imports, right? And this is the UDFs. These are the UDF functions that we are deploying and the jar files, right? Basically, so it's bundling it up together to be used in further in our program, and all happening, within under a second, within milliseconds, right? Now, next up is what we're going to do is we're going to use our sentiment analysis tools or sentiment analysis core NLP to create a data frame, right? And this data frame will contain the actual text from our tweet data frame. And alongside the text, we're going to attach the sentiment of that particular text, right? So one column will be a text with the tweet, another column will be the sentiment about the tweet in the analyzed data frame. So you can see that how we are transforming the data without actually saving them, back in any system. You can definitely save that in a temporary table, but we are not actually making any data hops here. We are still transforming the data, but we are not making data hops, and nothing going on in our memory of the computer. So basically, you don't need a beefy chunk of beefy computer, lots of memory, lots of in memories. You don't need all that when you use the Snowpark API, because all that's happening is in a lazy execution fashion. In the back end, you're generating those SQLs, but you're not fetching the data. You're not going back to the server and then making those changes to the data actually. So that enables us to do the transformations on the fly, right? So next time when you think about building a pipeline, and making changes to the pipeline or transforming the data, think about Snowpark, because that can help you make your pipeline faster by all these techniques that we have involved in, that we have developed in the Snowpark API. So back to our code, the analyzed data frame made of text and its sentiment. That's this data frame is very useful. You can do multiple things with this particular data frame. So as a matter of fact, what I'm going to do is I'm going to extract the happy tweets from this analyzed data frame. And in order to do that, I'll create a new data frame called as happy tweets. And I'm going to filter this analyzed data set for sentiment score 3. So wherever the sentiment score is 3, which is actually a happy sentiment, if you go and look at the Stanford Core NLP, I'm going to save them into happy tweets. And then next, let's retrieve the happy tweets and show first 10 rows of those tweets. So basically, this is where all these transformations will actually compile and execute. And then we will make a data hub at this step, and then we'll go to the we'll go to the Snowflake server and actually run this code in the warehouse. All the all the transformations will run inside of Snowflake. So you don't need a beefy virtual machine or beefy EC2 instance or any other virtual machine or VM in Azure. So you don't need all that. So let's see what happened after we finished creating our UDF. So here again, not a lot happening when we actually try to create another data frame, because again of that lazy execution. Nothing happened when we created the happy tweets data frame, but then when we actually called the show method, then it went and created the queries for the transformations, right? And actually generated the text and the sentiment. So up until this point, you can actually either visualize and then go on and do further transformations. I am happy with my output, so I'm just gonna select a write method and write or actually overwrite the happy tweets in a table called as demo happy tweets, and in the print that in the session. So that we can see that whether the happy tweets is actually saved or not. So this is what it's showing right here. Next, let's go and see this table inside the Snowflake as well. And actually, let's go down and grab the same query that it ran against the server. So yeah, so this is the query that ran against the server, right? If you go back, yeah, so this is my account that I use for this demo. So if I just type in this and run it, does not exist. Okay, because you're not using the fully qualified name. Or you can use database this, and then we are using public schema, right? If I'm not wrong. So going back, yes, schema is public. So you use a schema public, or you can use a fully qualified name, right? Here, and there you go, voila. So you have the tweets and then you have the sentiment. Now, remember, we only saved the happy tweets here. So these are all happy sentiments. Fantastic. So this concludes the hands-on lab session today. I really want you to look at some of the key features of the library. So do feel free to go to docs.snowflake.com. Again, the links are API reference, and then you go to Snowpark. This whole hands-on lab is already there, deployed as a guide, so you can go and look that guide. And anybody who lagged behind or missed some steps, you can again rerun this whole hands-on lab using the HOL or using the guides that we have prepared in quickstarts.snowflake.com. You can also refer to the developer guide. It should be very useful, for real-world programming for DataFrame Reader and not just this hands-on lab. So calling you guys out on using this and making the best use of Snowpark as you can. So for those who have stayed with me, I want to share some bonus lab example for using Snowpark and Java UDF. We are going to write a program to check if the tweet has personal identifier information, which is PII, in the text. And particularly, we will be looking for emails, SSN, phone numbers in the text. And you can also extend this example as per your need, but the basic code will almost remain the same. So let's go into it. Right, so let's clear create a new example. So what we're going to do is create a new file, and I'm going to call it as has PII and .scala. Right. In this example, we'll start by creating some boilerplate code. And for that, let's copy paste the code that we created with this until the tweet data, right? Go back, paste. So we are not going to use any of our sentiment analysis for this. So we just get rid of these 4 libraries. We don't need that. We will import another library we will use for this example. And we are primarily going to do the PII check using regular expression, right? So we need to import java.util dot regex dot pattern, right? And we are also going to be using the properties, which is already here. Cool. All right, so let's move on. And I'm going to call this as PII. So has PII, right? This object has PII. We don't need all this. So let's just increase some of the real estate in our code. We are not doing anything with the analyze. So let's start by creating a main method, right? In this main method, what we're going to do is first create a session. Once we have the session, we're going to call implicit on it so that we can use the short names for column. Then again, we need the file format, we need the original data set, and we need the options. So I'm going to add one more option here because I am going to save this as a table. So I'm going to make use of our validate functions, and it goes like this: validate UDF. Now, why I'm doing this is because the tweets can have any text, any language text, and sometimes it has, UDTF content, which is not unreadable for some format. So I'm just going to call that out and say, don't try to validate the UDF format. Just take it as the tweet. Don't try to modify it, right? So let's just call it as false, right? So validate UDF is false. And you can look at all these options in Snowflake document for reading a CSV file. Now we are reading the same file, and we have the tweet data frame, right? So instead of reading 100 tweets, let's read 200,000 tweets and see how long it takes. So I'm going to read 200,000 tweets. You can definitely read 1.6 million tweets. It doesn't take long. It should be under a minute. For this example, I'm just going to read 200,000. Again, you can do as many as you like. Now, what I'm going to do here is, instead of just showing the tweets, I'm actually going to write it to a table so that we can compare the before and after results, right? That's what we do in so many of our data science and data engineering project or feature engineering project, where we save a copy of DataFrame and then creates a lineage on that data. So let's just write it off in a table. And then again, the command is mode, write mode, and I'm going to try to override the table if it exists, and then save it as table. And I'm going to call that table as tweets. Right, so we have our tweets data available. Now, let's see if the tweet table is created first, right? So let's use our session variable, and let's just call a simple SQL, If you don't want to do this step, it's completely up to you. If you're not familiar with simple SQLs, you can just use your code. You don't need to write any SQL. I'm just going to say, hey, tell me if the tweets table is available, right? So describe table tweets and then show. Or tell me whether the tweets table is available or not, right? Now, let's use the tweets data coming from this table and then try to analyze the tweets, right? So I'm going to put this in a value variable, call it session dot table, and call my table as tweets. Right, I'm calling my table tweets. Now, next, what we're going to do is for each item, for each row present in the tweets, I'm going to do a little housekeeping, right? First, let me clean this data. What if there are nulls in that data? So let's just do a quick housekeeping, right? I'm going to call this as housekeeping. Simple, just create a new data frame. Let's call it cleaned. And what I'm going to do is I'm going to use the tweets and just going to say where. Right, so we have text column in this tweet, right? So the text column is not null, simple, right? Also, if it has any, if you want to drop any column, if this table has any column, so you can use drop, right? Right now I don't have any column. I'm just saving this as a text, right? And now let's create a class. I'm going to call it PII. And this is the class and the function inside that class we will create. We will use that code or that function as a UDF, as a user-defined function. So you can see how we can reuse code without actually building a new code further in the pipeline. You can keep using this code over and over, and this code will sit in close to the data. So you can call this function and check PII in any text, not just these tweet state table, but any text. So for this, let's create variable targets. And what we're going to do is we are going to define the regular expression pattern in this targets. Basically telling the system that, hey, save off my regular expression patterns in, let's say, an array, right? So you can use any preferred text patterns that you like for something familiar to your organization or something coming from the internet. I just copy pasted some regular expression patterns for phone numbers and SSN and email addresses. These are the common patterns. You can find them easily on internet. They are very, if you search over the internet, you'll find these patterns and many more. Like, for example, you can add VIN number of, regular expression for VIN number so that you don't show VIN number of the car. You can have health information as PII. You can have some other sensitive information as regular expression. You can expand this array as much as you want. So just for this example, I'm going to use these three regular expression. All right, very well. Now we need to map this pattern, right? So for this, what we're going to do is I'm going to create a patterns variable, and then I'm going to use this targets, right? So I'm going to use targets and map this pattern. So any value that I pass to this, it's going to go through the pattern search, right? So this is the Java function. This is Java method. So I'm just going to call that Java method over that text that we pass, right? Next is let's define a method inside this class which we will use to call these patterns. So I'm going to call this as has small ii, so has pi, just a constructor. So use, and then I'll pass strings of text to this method, and in return I want a Boolean if it's true, if it does follow the pattern or not, right? So if it follows the pattern, then I'm going to save this off in a different table. But for now, let's just create this method. So in order to create this method, I'm going to call patterns, right? So this is my variable the earlier that I created. I'm going to use that patterns, right, and then map this pattern over the string that I just received, right? So for this, if you look at the Java pattern library, you'll see these functions. It's called matcher actually. And then you will pass the string to it. And then you'll find, if you find something, right, what you should do. And if you don't find something, then what should you do? So you find something on that particular string based on the pattern that we have selected. And there's a variable, there's another method that you need to call upon that, and then it's called fold. For now, I'm not going to use it, so I'm just going to say it false. And then what else? So keep searching, basically. Keep searching for the next available text after this. So this is in short our PII detection tool, this detection code that we're going to use. We can use it over and over, like I said, on any text, not just this, right? So we created a piece of code that can be reused. Now, how do we reuse it? Using Java UDF, right? So before I do that, I'm going to create a lazy evaluation variable, right? I'm going to call it lazy eval PII, right? And then in this, I'm going to initiate this as an object of this PII class. Now, in a different data frame, I can actually use this PII object and call that method and pass the text to it. And in order to do so, let's create a variable, or actually a data frame. Let's just create a data frame by using the user-defined function that we just created, the HasPI, right? So I'm just going to call it check PII, right? So UDF. So this is the function that makes a call to the user-defined functions based on what we pass. So I'm going to pass a string, and I want, whenever I call this, so this is lambda calling as PII X. Basically, I'm calling the PII method from the SPII class, sorry, the PII class, right? Once I do that, made a call, successful call to the UDF, right? Now, let's actually create a data frame using the real value, meaning let's pass the clean data set that we prepared right here and pass it through the PII to generate the tweets that has PII information. So let's do that. So we will call this as with PII. So any tweets that has PII. Oops. There you go. And for that, we will use our cleaned data set. And just simply using the where method and the check PII, and then pass the text, right? Pass the text column. and then simply show the with PII will suffice, but I actually want to save this, right? So let's save this. So with PII, that's my data frame that I just got. Write.mode into save as table. Oops. So mode, save mode override. You can just say save mode dot override and save as table, and then the name of the table. So I'm just going to call this as PII tweets, meaning the tweets that has PII, right? And then in the end, let's just close this. I think we had to open. Yep. So the thing is closed. Now let's run this and see if we actually get the results for in the PII tweets and save this as a table. And let's just do a quick code check before we do that. So yeah, so these are single codes. This should be single codes. I think everything else looks good. Just gonna move this a little bit just so we can see the code clearly, right? So yeah, we're missing. This should be called as lambda. And okay, so my class name is, my object name is has PII. So I'll just rename this to capital H. There you go. All right, save all. Now let's try to run this. So SBT, run main, and has PII. All right. Okay. All right, so looks like we are good. Let's go back to Snowflake and see if we actually created the table. Star from first table was tweets. So this is where all the original data sits right now. So if I go and look at this, all right, and if I say select count star from tweets, 200,000. Now let's see if it created the tweets table that we want. So select star from PII tweets. So any tweets that has PII information as per my regular expression. Yes, so it has email. This one has email. This one has phone number. So as you can see how easy it is to create some examples, such examples like PII detection so easily using Snowpark and Java UDF, and many more things that you can do. With such example, very easy use cases, reusable code, all at one place using Snowpark and Java UDF within your Snowflake environment, rather than posting the data or exporting the data out of Snowflake. You can do all this within Snowflake itself, an easy and very cheaper way, rather than bringing up a big EC2 or a big virtual machine for your environment. I thank you everyone for joining this session, and I request everyone to after this call, go ahead and go to our lab material, go to quickstarts.snowflake.com, look for getting started with Snowpark, and once you're in that guide, go ahead and rerun it, replay it, and check it with your own pace. There are also group discussions in Snowflake community, and we want to hear from you of how and what do you feel about Snowpark and UDF. So with that, I sign out. Thank you so much for watching again.